Welcome back, everyone. We're going to be solving LeetCode 226, invert binary tree. So we're given the root of a binary tree. We need to invert the tree and return the root. So we take a look at example 1. What do they mean by inversion? We're given 4, 2, 7, 1, 3, 6, and 9 as the tree, and we can see that all of the left and right nodes are going to be swapped. So in our given input, 2 and 7 will now be swapped. And then the values from the 7 node are 6 and 9. They're going to be 9 and 6 on this side. So every time we run into a left and right node, we need to swap them, right? Super simple. So we're going to use breadth first search to solve this. So we're going to use a queue. We'll say from collections import dq. We will say our queue is going to be equal to a dq where we initially put the root on. And we will say while the length of our queue is not equal to 0, what are we going to do? We are going to say our node is going to be equal to queue.popLeft, right? We need to take from the front of our queue. Okay, now we need to check and make sure that the node is not null first. So we'll say if node is not none. What are we going to do? We are going to say node.left comma node.right is now going to be equal to node.right comma node.left, right? We're just swapping the nodes. And then after that's done, we can say we can check for any children nodes and append them onto our queue. So we'll say if node.left is not none, we will say queue.append node.left, and we will do the same thing for the right side. Is not none, queue.append node.right. And then they want us to return the root, so we can just say return root at the end, and that should give us our answer. So let's run this. Runtime error, none-type attribute has no left. If node.left is not none. Both of these should be inside of our node. We have to check if that node is not none first. Okay, yep. So we pass all 3 test cases. We'll submit. Perfect, it does run. Okay, time and space complexities. Space complexity is going to be bound to the length of our queue. So that is going to be O of n. And the space complexity is going to be O of n as well. We have to traverse every single node in our tree and then swap all the children essentially. So we're going to be touching all the nodes at least once. So that'll make our time complexity O of n for this problem. All right, that'll do it for LeetCode 226.